Okay, welcome to 6.2. Let me share my screen with you. Hope you're doing real well. So we'll start by warming up. Tell whether X and Y show a positive, negative, or no correlation. You should remember this. So go ahead and do those. Okay, hopefully you got this was negative, right? Because as X gets bigger, what's happening to the Y values? It goes down. Okay, or think of it this way: as the Y values get bigger, what happens to the X values? They get smaller. So that's a negative correlation. On two, hopefully you got no correlation because it's just a mess. Here, positive correlation, right? As X gets bigger, what happens to the Y values on the points? They get bigger too in general. And then this one, no correlation. Okay, cool. All right, so your learning targets, say it out loud and proud. I will be able to write and evaluate an nth root of a number. And obviously we'll have a number plugged in for n. Okay, so here's a little fun exercise. What do you think 8 yards of gravel looks like? Okay. Students and other folks may not know that gravel is generally sold by the cubic yard, and the word cubic is rarely stated. So 8 yards refers to 8 cubic yards. Okay. So here's a question for you. If the gravel were dumped inside a cube-shaped container, what would the dimensions of the cube be? Think about that. Remember, 8 yards refers to 8 cubic yards. Hopefully you said 2 yards on each side because 2 times 2 times 2, length times width times height, 2 times 2 times 2 is 8 cubic yards. Okay, what would the dimensions be in feet? Hopefully you know that there's 3 feet in a yard and therefore it would be 6 feet on each edge. And what would the volume of the cube be? 2 times 2 times 2, unless you're doing it in feet, in which case it would be 6 times 6 times 6 cubic feet. And that is 216. So is 216 cubic feet the same as 8 cubic yards? Answer is yes. Okay, so we're going to be getting into cubes and cube roots and stuff like that. Okay, so here's some, and you probably are aware of this a little bit, but if not, that's okay. We're going to learn it all together now. Okay, recall that that you cube a number as follows, right? 2 to the third power, 2 cubed means 2 times 2 times 2. It's whatever the base is multiplied by itself 3 times. And just like we can take square roots, which basically says, okay, what number or numbers multiplied by itself 2 times would get me the radicand. Remember, that's the big number under the radical sign. Here we're saying what number multiplied by itself 3 times. So like the cube root of 8 is equal to 2 because 2 cubed is 8. Okay. All right. And notice here, and we'll get to this in a bit, but notice how if I rewrite the cube root of 8 as 2 to the third, I have a root index here, the small little number of 3, and I have an exponent of 3. And 3 divided by 3 is 1. And notice this is like 2 to the first power here. Okay, so you're going to work with me, and you're going to use a cube root symbol to write the side length of each cube, okay? Then find the cube root, check your answers by multiplying back out. Okay, so here's an example of one. 27 cubic feet. Well, if it's a cube, right, it means the length, the width, and the height all have to be the same. So we're going to be multiplying number times 3. So we want to take the cube root of 27, which is 3. So in this case, it's 3 feet. And notice 3 times 3 times 3 is 3 cubed, which is equal to, gets us back to 27. Okay. All right. So try, what do you think for 125? So in other words, what number multiplied by itself 3 times, not multiplied by 3, but multiplied by itself 3 times would get you 125? And hopefully you saw that it's equal to 5 because 5 times 5 times 5 is 5 cubed, which is 125. Okay. Notice how quickly when we multiply with cubes, the numbers get big, right? Like just by going from 3 up to 5, it's already gone from 27 to 125. All right, try this one. Okay. And here you're getting a hint. The ones digit is a hint. Because what's the only number when you multiply it by itself 3 times is going to get you something that ends in a 5. Something that ends in a 5. So in this case, it's only 15. So look at that. Just going from 5 cubed to 15 cubed, you increase by that much. It's going to be probably a really good idea, just like you learned the perfect squares numbers up to 400. And, like, so you know that the square root of 169 is 13, for example. Important to know that the cube roots, it's going to make your life a lot easier. So obviously 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed 64, 5 cubed 125, 6 cubed 216, 7 cubed 343, and then beyond that I really wouldn't worry about it too much. But if you know some of those basic ones, it's going to make your life so much easier. So you might want to make some flashcards with those or make a list, something like that. Okay. All right. So let's estimate the positive nth root. Okay. Notice they've only asked for the positive. It's because there could be a negative, right? There's a number that if we, that's a negative, if we multiply by itself, we're going to get 0.5. Okay. So let's see. And we have to match it with the ones that are down here. Okay. Well, we know 5 squared is 25. So what number times itself maybe would get us to about 5? I don't know. Well, let's see. Yeah, about 2.2, right? 2.2 times 2.2. Yeah, that's about 5. And that's about where C is, okay? What about to get a decimal, like a number less than 1 but greater than 0? Is it going to be a bigger number, the square root of 0.5, or a smaller number than 0.5? Remember, when you multiply a decimal by itself, you get a smaller number, right? So it's actually going to be bigger. So hopefully you thought, well, about 0.71, right? And again, you can estimate these if you want to use your calculator. You can use your calculator. Okay, what about the 5th root of 2.5? Wow, that's going to have to be fairly small because we saw how quickly we got up to 25 just from 2.2. So is it going to have to be more than 1 though? Yeah, because if it's less than 1, it's just going to keep getting smaller. I'm going to guess that it's probably like B there, but a little over 1. Yeah, 1.2. Okay. How about for the cube root of 65? Well, I just told you the 4 cubed was 64. So a number multiplied by itself 3 times giving me 65 is just going to be a little bit more than 4. Okay. What about for this one? What do you think for 55? Yeah, well, looks like it's probably going to be, it's going to be a little less than 4.02, right? Because that was 65. So I'm guessing it's going to be D. Oh, yes. And then by process of elimination, it's F, which makes sense because we're going up all the way to 20,000. We would expect it would be pretty big. Okay. All right. So here, let's jump into the first main core concept here. Okay. So because a to the 1/2 power, so the exponent's 1/2 is a number whose square is a, you can write a to the 1/2 is equal to the square root of a. Okay. Similarly, the cube root of a is equal to a to the 1/3. Okay. And that you would suspect then the 4th root of a, the quartic root as we call it, would be equal to a to 1/4. Okay. So the general form you're probably seeing would be that whatever the root index is, whatever number that is, that's going to equal a fraction with 1 as the numerator. Okay. So like if I was taking the 10th root of x, I would write that as x to the 1/10 power. Okay. All right. Now we're going to look at some different examples. Okay. Different possibilities here. So let's let n be an integer greater than 1. Okay. So it's going to be 2, 3, 4, 5, 6, 7, 8. And those are going to be our, you can see here, it's going to be our root index. Okay. And a is going to be a real number, any real number. So it could be negative, right? Okay, let's look at the possibilities here. If n is odd, meaning it's 3, 5, 7, 9, etc., then a has one real root, one real nth root. Okay, so here's an example of that. Okay, so we're going to have a is negative 27. Our root is 3. So we would write this as the cube root of negative 27. Well, what's the only number in our universe where if we multiply it by itself 3 times, we can get a negative? That tells you it's going to have to be a negative. And hopefully you said it's negative 3, right? So notice positive 3 doesn't work for that, right? Positive 3 cubed is equal to 27, positive 27. Okay. Okay, what about if n is even, right? So now we're not taking a cube root or a fifth root or a ninth root. We're taking a square root or a quartic root, fourth root, or the sixth root, okay? And our radicand is greater than 0, okay? So here's an example of that. Okay, we're taking the fourth root of a positive number, 16, okay? It's going to have two real nth roots, okay? And you might be saying, well, how could that be? Why wouldn't it just be, why wouldn't there just be one? Why wouldn't this just be 2? Well, because they're asking for all real roots. And remember, if we multiplied -2 times -2 times -2 times -2, it would end up being a positive 16. Okay. If they just ask for the square root, in general, they're just asking for the positive one. But if they ask for all real roots or something, then they also want the negative one. Okay. All right. Well, what about if n is even? Okay. So we're looking for a square root, a quartic root, sixth root, eighth root, 10th root, and a equals 0. In other words, what is like the root of 0? That's always going to be 0, right? If I wanted the square root of 0, isn't 0 times 0 equal to 0? What about the fourth root of 0? Isn't 0 times 0 times 0 times 0 equal to 0? Okay. All right. Fourth example. What if n is even again? So like a second root, fourth root, sixth root, and a is a less than 0, meaning it's a negative number. Can you take the square root of a negative? We saw we could do cube root, right? Because we know if we multiply 3 negatives together, it's going to get us a negative. But can you multiply a number by a negative number twice and get a positive number? No. 4 times? No. Any even number is not going to work. So that would be no real roots. Okay, you'd say no real roots. Technically, you'll learn in Algebra 2, it's really kind of, we're getting into what we call imaginary numbers. For example, the square root of -2 or of -1 is equal to I, lowercase I. Okay, so here's some practice problems. So let's try these. So go ahead and give this a shot. First, remember, think about how you would write it. It's saying find the cube root of -125. So you could write that like that. And what number multiplied by itself 3 times will get me to -125? -5, right? Okay, notice it's not +5. +5 would get us +125. Okay, what about this one? Rewrite it in radical form with the root index of 6. Okay, you know this number's got to be, obviously it's a positive number, but it could be a -2, right? We're going to have 2 roots because it's an even root index and a positive number, but it's got to be pretty close to 0, right? Think about what it is. Good, 2 and -2. Awesome. Okay, let's try a here. The cube root of -8. Ooh, negative. And it's an odd number here. Can we have more than one? No, it's got to be just the negative. And what is it? -2. Okay. Notice here, this negative is on the outside, right? So we want to do the cube root first. That's like a grouping symbol. And then we'll slap the negative on at the end. So what's the cube root of 8? 2. So we have -1 times 2, which is -2. All right. Try writing this one into radical form first. So remember, if you look back here, a to the 1/4 is like taking the fourth root of a to the first power. Okay, so in other words, if I put a little 1 in here, it's like this goes to here, and the denominator, whoa, becomes my root index. Okay, and that's going to be the case on all of these. All right, so how many real roots do we have of fourth roots of 16 do we have? Hopefully you're saying 2, and what would they be? Okay. Oh, no, I'm sorry. This is not, this is just saying evaluate the expression, my bad. So they're not asking for the negative root. They're asking just for the positive one in this case. I know that's a little confusing, but notice that's different than the instructions where it says find the indicated real roots. Okay, so what is this one asking for? Write this in radical form. So it would be the fourth root, right? Because denominator comes to here. Numerator is what we're putting here. And what is the fourth root of -16? Is there one? Can you multiply a number by itself an even number of times and get a negative? No. Okay. And again, like I said, there's an imaginary one that you'll learn about in Algebra 2. Okay, this would be a good place if you want to take a quick break, stretch a little bit, or if you're doing this in 2 parts, this would be a great place to stop. All right, but let's keep going here. All right, just taking this a half step higher. So rational exponents. Okay, if we let a to the 1n be the nth root of a, and we let m be a positive integer, then this is going to take us beyond just like 1 over, but it's going to mean like if m and n can be anything, then how would we write that? Well, kind of like what we saw, the denominator becomes the root index, the numerator gets multiplied here. So notice how a to the m over n becomes the nth root of it all raised to the m power. So 27 to the 2/3 becomes, the 2 goes outside, the 3 goes inside as the root index, okay? Then we would do the cube root of 27 first, which is 3, and then 3 squared is equal to 9, okay? So rewrite each of these when we evaluate, rewrite them in radical form, okay? So go ahead and try that one. Think about where the 3 goes, think about where the 4 goes. Okay, so then we take the 4th root of 16, and again, they're not asking for all real roots, so we're taking the positive one. We're going to take 2, right? And then we're going to cube that, which is 8. Okay, all right, so using these as a guide, rewrite this one. Pause the video and rewrite it. Okay, so hopefully you did that. And then what's the cube root of 27? 3. And then 3 to the 4th is like, well, 3 times 3 is 9. So isn't it like kind of 3 squared squared? So it's like 9 squared, which is 81. Okay. All right, so try these. What number multiplied by itself 3 times is going to get me negative 125? Okay, you got negative 5. Rewrite this one. This is what we call fractional exponent form. So I want you to write this in radical form. Think about where the 2 goes. Think about where the 3 goes. If you're not sure, go back and look there. Put it like that. Okay, what's the cube root of negative 64? Negative 4, and then negative 4 squared is positive 16. Okay, try number 3. All right, I'm back. So this is saying basically we want to take the square root. Notice I didn't write a 2 in there. I could have, right? I could have put a 2 there, but we know that if there's no root index, we're always talking square roots. So I could have done that. Square root of 9. Again, we're evaluating the expression. So we're assuming when they, unless they say nth roots, all nth roots, we're assuming they want the only one that's possible or the positive one. That becomes 3, and 3 to the 5th is a lovely 243. Okay, number 4, basically saying what's the 4th root of 256 raised to the 3rd power? Okay, well, you know that 16 times 16 is 256, right? What times itself will get you 16? Oh yeah, 4. So it's basically saying what's 4 cubed, which is 64. All right, so let's do a few word problems. The radius r of a sphere, oh man, that would be so fun to play with, is given by the equation. There you have it. Notice that's to the 1/3 power, where v is the volume of the sphere. Okay, so v there is the volume. Find the radius of the beach ball to the nearest foot. Use 3.14 for pi. Oh, and they tell us the volume is 113 cubic feet. Okay. Oh, we don't have to memorize this formula. Thank goodness. Yes. Okay. All right. So what are we going to do here? We're trying to find what? We're trying to find r. Well, then I hope they gave us v. Oh, yeah, they did. And they gave us somewhere to plug in for pi. So really, it's just evaluating the right side of that equation, right? Because it's r equals. All right, so see how we plugged in, okay? Probably want to simplify this, so let's do that. 239 and then 12.56. And then we're going to take the what? We're going to take the cube root of that and then multiply it to the first power, which means we don't need to multiply it, right? So again, you can use your calculator for that. So it's about 3 feet. And that makes sense. Radius about 3 feet, be there, across there, and then another 3 over here. Yeah, it looks like it's about a diameter of 6. That's a pretty big ball. Okay. All right. Here we're going to calculate the annual inflation rate, R, in decimal form of an item that increases in value from P to F over the period of n years. Okay. And there's our equation. And again, we don't have to memorize it. Okay. Find the annual inflation rate to the nearest tenth. Which variable is that? Oh, yeah, R. They told us that right there. Of a house that increases in value from 200,000 to 235,000 over a period of 5 years. Okay, so P to F, right? So we're talking about present, future, right? And N is 5, period of N years, right? So we wrote the equation. All we're going to do now is plug in because we're basically solving for R. Okay, we can simplify inside there. So it's really, if you think about it, we can cancel off the 3 sets of zeros, and 235 over 200, 5 goes into both of those, or you could just do the division, you get the decimal there. So we're basically saying what's the 1/5 power, the 5th root of 1.175. Think about it a second. Is it going to be bigger than 1 or smaller than 1? It's going to be bigger, right? Because the only way we can get up to 1.175, multiplying a number by itself 5 times, if it's a little bit bigger than 1. But it's probably not a whole lot. So it probably came out to, well, it did come out to approximately 1.03278, because then when I subtracted 1, I got 0.03278. All right, so what would the percent be? What do you have to do to convert that to a percent? Move the decimal over twice, right? We're going to go doop, doop. And so what's our answer? And I think they asked us to nearest tenth. So what would that be? It's 3.278. So that becomes 3.3%. All right. Find the average the average cost of college tuition, or the average cost of college tuition increases from 8,000 to 13,500 over a period of 8 years. Find the annual percentage rate to the nearest 10th percent. Yay, we don't have to memorize the formula still. Yay. Okay, so what are we going to plug in here? P, 8,500. F, 13,500. What's N? 8. Very good. Okay, so simplify inside, cancel the zeros, do the division. Okay, it's basically saying cancel off, and 5 went into both of those. You could basically, on your calculator, again, if you want to, again, remember doing that. Turn your calculator on the side. You have a button there that says X to the Y is an exponent. So X is the base, Y is the thing. I'll let you look for it there. It's kind of right in that area, right in there. Okay. So you literally would type in, well, let's do 27 divided by 18. It's 1.5. Oh, 27 divided by 17, sorry. My bad. 27 divided by 17 is that big decimal, okay? And basically what I can do is I can just kind of leave that there. I can hit that X to the Y button. So that's going to make the 1.588 of my base. And then by hitting that button, it's now saying enter your exponent in. Well, what's 1/8? So I could put a parentheses and then 1 divided by 8 end parentheses, and then hit equals, and I would get this. Okay, or you could realize that 1/8 is 0.125 and just go that way. All right, so yeah, so it rounded it to 0.06, 1.06, so which is very similar to what I got in my calculator there. And so that becomes 0.06. So nearest 10th percent is it's approximately 6% annually. All right, and I think that does it for 6.2. A lot in there. Just make sure you go back and have your notes available for you when you work on the BIM stuff. I'm here to help you. All right. We are done with 6.2. Have a great day.